The first index law is telling us how to multiply numbers or variables in index form with the same base. Before applying index law, we're going to check out with these two examples manually to see how it works and compare to the index law. So with the first example, if we do it manually, so it's 5 to the power 3 times 5 to the power 2, or we say 5 cubed times 5 squared. Write this one, these two numbers are in index form. If I do it manually, I'm going to rewrite them in factor form. So 5 cubed is 5 times 5 times 5, 3 number 5s times together. And then we times with 5 square. 5 square is 5 times itself twice. And now we have to bring it back. We have to bring these back into the index form again. So the base now is still 5, but what is the index? So we have to count how many 5 in here. 1, 2, 3, 4, 5. There are 5 number 5. So the index form, the index here is little number 5 on top of the big number 5. So 5 to the power 5. How about the second number? 2 squared times 2 to the power 4. 2 squared is 2 times itself twice. And times with 2 to the power 4 is 2 times 2 times 2 times 2, 4 times. And I have to bring it back to the index form again. The base now still 2. And the index is 1, 2, 3, 4, 5, 6. So it is 2 to the power 6. Remember for me, when you do this, you have to make sure that the base are the same, which is number 5 in the first example or number 2 in the second example. The index can be different. This one is the formula for the first index law. So we can use the first index law that multiply numbers or variable in index form with the same base to do these two examples. And we don't have to do it manually. So the first index law states that a to the power m times a to the power n equal a to the power of m plus n. So in here you have to remember the base has to be the same. The index can be different. And then the result, you have to keep the base, and the index is the addition or the sum of these two indices. Let's check it out with the first two examples. The first two examples, they are exactly the same, but these two, I do it manually, and the results are here. So this one, I'm going to use the formulas of the first index law to see if the result is exactly the same or not. Okay, so here, the first thing I have to identify is they have the same base. So I can use the first index law because it's multiplying. And according to the first index law, my results and equal, I have to keep the base, which is 5, and I have to add the indices, which is 3 plus 2. So my final answer is 5 to the power 5. Exactly the same with the when I do it manually. How about the second example? The second example is the base 2, 2, and multiplying. So I'm gonna apply my first index law, and it's equal the base still 2, and I add the indices together, which is 2 plus 4, and it's equal to the power 6. Exactly the same. When I apply index law and doing manually, the answer is the same. How about with this number, 10 times 10 times 10 to the power 4? Remember for me, when a number or a variable standing by itself, no index, it means there is number 1 hidden here. It means 10 to the power 1 times 10 to the power 1. But in mathematics, we do not write 10 to the power 1. We write 10, and we have to understand that it is 10 to the power 1. So I just write number 1 on top of 10 for you to easy to understand this example. So it's equal because these bases are the same, which is number 10, and they are multiply each other. So I can use my index law, the first index law. So it's equal 10 to the power of, I add all the indices, 1 plus 1 plus 4, equal 10 to the power of 6. This is your final answer. How about letters or variables? We do exactly the same. We have to make sure that the base is Q here are the same. And they are multiplying, then we can use index law number 1, the first index law. With the first index law, we have to keep the same base, which is Q. And then we add all the indices together. So it's equal Q to the power of 47. This is your final answer. How about this example? G to the power 15 times G to the power 12. Remember, for me, G stand by itself is G to the power 1. And here, with the first index law, we're going to keep the same base, which is G. And we add all the indices, 15 plus 1 plus 12 equal G to the power of 28. Next example. So you're going to experience different example with 4. It's not P to the power 7 times P to the power 4. There are number 4 and number 5 in front. So the coefficient are 4 and 5. So what do we do? So with this one, if we rewrite these two numbers in the factor form, it's going to be 4 times P to the power 7 times 5 times P to the power 4. Actually, in factor form, we have to write P times P times P times itself 7 times and P times itself 4 times in here. But you guys know indices, so I just shorten it up. So I can rearrange because A times B equal B times A. So in this case, I can rearrange numbers close to number and letters close to letters. So it equal 4 times 5 times P to the power 7 times P to the power 4. And you can see here, 4 times 5 is 20 and P to the power 7 times B to the power 4. Using the first index law, you will have P to the power of 11. So your final answer is 20 P to the power 11. Next one and the last one. So we use the same thing. So it's equal, we just get number times number. So 5 times 6 is 30. And then P, the same index, the same base, P to the power 4 times P to the power 2. So I'll just write that down. I think I just write this one down. 5 times 6 and then times with P to the power 4 times P to the power 2. And then another pair is Q squared and Q to the power 7. Write that down. So times Q squared times Q to the power 7. And it's equal 5 times 6 is 30. P to the power 4 times P to the power 2 or P squared. Using index law, you're going to keep the base, which is P, and then add all the indices. So P to the power of 4 add 2 and times with Q to the power of 2 plus 7 using the first index law as well. And your answer is 30 P 6 Q 9.